Hello user, welcome to my channel Learning with Khatak. In the second part, we will show that how to create a KNN model and then how to train the model and how prediction will be made by using this model. If I go through the first part, in the first part we just look at the shape of the dataset, that how many samples are inside the datasets, how many classes are there, how many samples inside a particular class. Because IRIS dataset is a balanced datasets having multiple classes, so there are 3 classes in the datasets, Virginica, versicolor and Setosa, and each class representing 50 samples. So here in this case we want to create a model. So this is basically the KNN object. We have created an object, and then KNN classifier in neighbor is equal to 1. So here if I run this, so I created an object and then train the model. Now how to train the model? For training the model, we simply use a fit method by applying with the object knn.fit x and y. So what is x and what is y? If you remember, x is basically representing a set. If you look at this, let me show you. Yes, x is basically store all features in x datasets. We store 4 columns in datasets x and in set x. Similarly, all the classes are stored inside the y. So here we provide we want to train our model on the whole datasets, on the whole features by providing their relevant class labels. So if I run this, so it gave me k nearest neighbors 2 and then predict model. So I want to predict, I want to make a predictions by using the same model. So if you look at this, ypred is equal to knn dot predict x. Predictions, how I want to make a predictions? By providing a samples from the x data sets, where all the features are stored. So I simply take a samples from the x set and then want to predict that either the model how the model predict, how much the model accurately predict. So if I run this, this give me a predictions and then accuracy of the model. Now what we have done here, that there is no testing data sets. All the models, all the samples are in the training data sets, are in one set x, and then we want to predict for the same samples. So now if I look at the, it gave me, definitely it gave me the 100% accuracy. If you look at this, 1 means the score is 1, the accuracy score is 1. Why is this give me 1? Because there is only one set, all the samples, all the features, all the samples are in one set, x set, and all the samples having the target class y are in the other classes. So that's why it's give me 100% accuracy. Now in the second part, we will divide the data set into a training set and testing set, and then we'll show that how a model predict. So okay, shape of the data set, number of rows, again the same things will happen here. So if you look at this, number of total number of sample is 150 and number of features is equal to 4. In XIRIS we only store total number of sample and features without class labels. Class label will be stored inside the y. Okay, if you look at this, now dividing the data sets, look at this, all the classes are stored inside the y, and now if you look at this, dividing the dataset into training and testing datasets. 70% of sample will be in the training and 30% sample will be in the testing set. Regardless of the first part, where we have stored 100% sample inside the training dataset, this time we divide the dataset into 2 parts, training and testing. 70% sample will be stored in a training, while 30% sample will be stored in a testing sets. So if you look at this, how I made it, training size is equal to 0.07. So it means this statement will divide the data set into 70 and 30% ratio. 70% sample will be stored in X training, while 30% sample will be stored in I testing set. This is represented basically X train, and X test. So 70% sample will be in X train and 30% sample will be in X test. Similarly, 70% class label will be stored in Y-train and 30% class label will be stored in Y-tester. So now I want to practically show that really 70% sample inside the X-train and 30% sample inside the X-test. So let me show that. So 1, 0, 5 and 4. So it means out of 150 samples, 105, 105 samples are stored in X-train with the 4 features. Similarly, how many samples in testing data sets? Now, if I look at this, so obviously 45 samples will be there in X tester. So I divide the whole data set into 2 parts, training and testing. 70% sample, 105 samples inside the training set, and similarly 45% is the testing set sum. So the relevant classes labels in Y-train. In the same way, we want to show that 105 relevant class samples inside the Y-train, and similarly 45 classes will be inside the Y tester. So now what I made here, I divide the data sets into 2 parts, training and testings. Regardless of the first part where there is no testing sets, all the samples are in a one set X and all the class labels are inside the Y sets. But here in this case 70% sample inside the training data sets and 30% sample inside the test data sets. Now model creation and training of the model. Again, since the process of creating an object, here I am going to create an object and then I am going to train the model by providing X train and Y train. What is an X train? If you look at this, an X train, okay, okay, in X train there are 105 samples, and in Y train there is 105 class labels. So I provided 105 training samples along with their relevant target classes to train my model. So here my model is get trained with in neighbor is equal to 3 with 3 nearest neighbors, and then predictions of the model. Now look at this one. I train my model by providing samples from X train and Y train, and then the prediction is made by providing the X tester where I store 45 samples. If you look at this, this is the 45 X tester where I stored 45 samples. So here if you look at this, now I provide samples from the testing data sets to predict whether my model predict the exact class or not. So I made it here the prediction, and then I want to check the accuracy. For accuracy, if you look at this, accuracy of KNN 5 on the testing set. So this will just give me matrix.accuracy underscore score Y test and Y pred. In Y pred, basically the prediction is stored, and then these predictions will be compared with the Y test. Y test contain the actual class labels. So if I run this, it gave me accuracy of KNN N5 on the testing dataset is 0.97. It's good accuracy, no doubt. It's a very good accuracy. It's just the my model misclassified 3 samples without 45 samples. I provided 45 samples from the testing data sets, and the resultant model will only misclassify only 3 samples. That's why I get an accuracy of 97%. Okay. Then accuracy on the, this is the accuracy on the testing data sets. Now if I want to check the accuracy on the training data sets, then if you look at this, 95%. I provided, look at this, I provided now Y train and then Y predictions. The model made a predictions in the later stage. If you look at this, this is the predictions basically made the my model, and then I provide the training samples from Y train data sets and give it me 95% accuracy. Okay. Then important topic is the cross validations. So cross validations will be covered in the next part. So wait for the next part. Wait for the next part 3. Thank you very much.